Okay, moving on to question 9. Prism has a width of 5 and a volume of 90. If the volume is half times L times W times H, what is the height? Okay. So first of all, we should take notice that the width and the length are actually the same because we see these little indication here. So if the width is 5, then the length must also be 5. So we just don't know what the height is. We were told that the volume is 1/2 times the length is 5, and times the width is also 5 times the height, equals to 90. So now we have 25 over 2h equals to 90. We can cross multiply the denominator over. We get 25h equals to 90 times 2. So 25h equals to 180. And now we just divide both sides by 25. We get h equals 7.2. Yeah, we don't even need to use square root for this bubble. So the height is 7.2 centimeter. Question 10. The base of a triangle is twice the height. So the base is twice the height. The base is 2x and the height is x. If the area is 169, what is the length of the base? So we have 2x times x divided by 2, just base times height divided by 2, for the area of a triangle equals to 169. The 2 get crossed out nicely, we get x squared equals to 169. Now we can square root both sides to get x equals to 13. The base, which is what they are asking, is 2x. And we just figure that x is 13, so the base must be 26 centimeter. Question 11. Ellie is twice as old as Kate. So Ellie is twice as old as Kate. If the product of the age is 18, how old is Ellie? So Ellie's age times Kate's age is 18, but we already know Ellie's age is 2 times K. So we can say 2k times k equals to 18. So finally, 2k squared equals to 18. We can now divide both sides by 2. We get k squared equals to 9, and taking the square root on both sides, we get k equals to 3. Question is asking for Ellie's age. So we can say Ellie's age is 2 times k, which is 2 times 3. So Ellie is 6 years old. Question 12. A larger square has an area 4 times a smaller square. So a larger square and a smaller square. If this has an area of 8, this has an area of 4a. The area of the two squares is 80. So I can say 4a plus a equals to 80. 5a equals to 80. Divide both sides by 5, we get a equals to 16. So this a is 16, and this 4a will just be 4 times 16, which is 64. What is the length of the side of the larger square? So now I can just let this be x. So I can say x squared equals to 64. X times x is the area of the larger square. Square root both sides, we get x equals to 8. So the side length of the larger square is 8. Question 13. A rectangle has an area 9 times the area of a square. Rectangle has an area that is 9 times the area of the square. One side of the rectangle is the same length of the square, so we'll just let this be the same, just x. Find the dimension of the rectangle if the total volume of the square and the rectangle is 250 millimeters squared. So I think there's a typo. They probably mean area. So 9a times a equals to 250. We have 10a equals to 250, and then divide both sides by 10, we get a equals to 25. So this a equals to 25. So now that we have this, so this would be my step number 1, step number 2. Step number 3, I can say that x times x equals to 25 from here, right? X times x is the area of the square. So x squared equals to 25. Square root both sides, we get x equals to 5. We also know that 9a is the same as 9 times 25 because a is 25. So 9 times 25 is 225. And then now I can also solve for L, which is the length. So I can say x times the length, x is 5, equals to 225. So the length must be 45. And there, that's the answer. They just want the dimension of the rectangle. So you can say this rectangle is 5 millimeter by 45 millimeter. So we were given a formula, electromagnetic force E, which is in volts, equals to the square root of W, so W is in watts, times R, and resistance is in ohms. So they're asking us how many watts are needed. So W is unknown. That's what we're trying to find. To produce an electromagnetic force of 20 volts. So E is 20. That's the one in volts, right? With the resistance is 5 ohms. So R is 5 ohms, right? So now you can replace the formula. E is 20 equals to the square root of W. We don't know, but resistance R is 5. So now you can square both sides. We have 400 equals to 5W. Because square and square root, they cross each other out. Now we divide both sides by 5. We should get W equals to 80. And that's the answer. So the W equals to 80 watts. (15) Formula that gives the relationship between the current I don't know, amps, I don't know what that is, equals to the square root of P, so P is in watts, divided by R. R is also the resistance in ohms. So the current is 10 amps, so that means I is 10. The resistance is 5, so R is 5 in ohms, and they're asking us what is the power in watts. So we can replace I with 10. We don't know what P is, but we know R is 5. Once again, we square both sides to get 100 equals to P over 5, and then just cross multiply the 5 over. We get P equals to 500. So that's the power in watts. And the last question, 16. On Earth, the distance to the horizon is given by this formula, d equals to the square root of 3h over 2, where d is the distance in miles and h is height above sea level in feet. How high does a person have to be to see 15 miles? So you see the h is 15, right? You were told that h is the height above sea level, and we were told that the distance is 15, yeah. So height is what we're trying to find here, because they're asking you how high does a person have to be to see 15 miles. So that will be the distance that the person can see to the horizon. So we replace d with 15. We square both sides. 225 equals to 3h over 2. Cross multiply. You get 250 equals to 3h, and then divide both sides by 3. We get h equals 80.3.3 repeating miles. Oh, in feet, sorry. The height is in feet. Okay, so that's it for 6.2. I'll see you in 6.3.